So now we see our breadboard here. We're going to show you hardware control over the LED. We have voltage supplied from our voltage rail to the input of our button. We have the output of the button connected to the input of the resistor. This is a 330 ohm resistor, orange, brown, which is 3 times 10 to the 1, which is 330 ohms. And then that's connected to the anode of our LED. And I'm going to show you another LED here. The long lead is the voltage side. The short lead is the ground side, called the anode and the cathode. And this is how I've connected it to the ground side, so from the voltage side to the ground side. So that would complete our circuit. And if you take 5 volts divided by 330, you get about 15 milliamps, 15 thousandths of an amp, which is perfect for driving this LED, as you'll see. So you can see that we have nice control over the LED. So that's our hardware control. That's not very exciting, but our next step is to actually hook this up to the Raspberry Pi and control it from the Raspberry Pi. So now we see our Node-RED desktop here, and these are our nodes, our building blocks, kind of like Lego bricks, where each of these contain a lot of code that does a lot of work for us. That makes hooking up things very quick and easy. Also, we see some nodes I've already placed here. These are inject nodes. This is our inject node here. This is our debug node. We can literally just bring them in by clicking and dragging. But I've already done that here. So let's take a look at what I built. I've got an inject node with a payload of a number value of 1. Now, the payload is kind of like the contents of an envelope. Everything in Node-RED is message-based, and that message is like an envelope that goes from one node to the next until it comes out the other end. And the payload is what's inside the envelope, and I could mark a address or topic or note on the outside of the envelope to tell me what's inside and the meaning or relevance of that content. But I've left it blank here, and we're sending a high, a level 1. This inject node sends a level of numeric value 0. Again, with no topic. This node actually connects up to a GPIO pin, and I've defined this as a digital output pin. I could set it up as a pulse width modulation output or digital output pin. But I've defined it as pure 1s or 0 digital output, and I've named it as the red LED. The other node I've got here is a debug node, which is very useful to see what's coming through at the very end in the form of a payload, which we'll see here in a moment. And I've connected these. Let me just disconnect this for a moment and show you how easy it is. I'm going to wire this up to the output. I'm going to wire up the inject node to the debug node, and the inject of a 0 to the output pin and the 0 to the debug node. And now I'm going to click on deploy. Anytime I make a change, I have to deploy. You see it's successfully deployed, and that means Node-RED is happy and is ready to go. So if I click the one inject node, you'll see what happens. Let me bring in the camera, and you see the camera view down here. And I'm going to click on the 1, and you can see that the LED has lit up. And I sent a 0, and then I sent a 1, and now I'm going to send a 0, and the LED is off, as you can see. And I sent a 0 over here. I'm going to send a 1. It's on. I send a 0, and it's off again. So I've now done software control over my hardware. This is the first interface project that you should do I'm going to clear out the debug node so that we can clear all this out. And you've just been able to replace that button with a computer software controlled button. And this is the beginning of interfacing. Now, I could just as easily replace this LED with a little bit buzzer. Notice the longer lead and the shorter lead. Well, the longer lead is the anode. And I'm going to hook that up to the resistor side and the negative side to the ground. And then I'm going to click on a 1. I don't know if you can hear that, but the buzzer's on. And now let me turn the buzzer off. And the buzzer is off. You can no longer hear the buzzer. And you can see that I sent a 1, and then I sent a logic level 0, and I changed the state of the output pin from a 1 to a 0, and we're using active high logic here. So the next step we want to do is go into showing you how we can take software control. So now what we're going to do is take our hardware button, and we're going to send that output of the hardware button. The voltage comes into the button. The output of that button sends a voltage to pin or GPIO port 6. And we'll be able to detect that. And then the output, rather than using the output, I can actually disconnect it to just prove to you that we're not going to use that output. But we're going to send it into a software LED. We're going to control a software LED on a dashboard using that button. So to do that, we need to go back and open up another browser tab, and we need to go to 192.168.1.101:1880, or whatever your IP address, and then add a :1880, but then you add a /UI, lowercase, and you'll get this kind of a dashboard. Now let me show you what we've got. This is it's called a browser tab for the flow, and this flow is called IoT. We have an input group and an output group of inputs. Right now we're not using any inputs, we're using a hardware button. But for outputs, notice we have a red-green LED. And at this point, it's green for ground. I like green for ground and red for voltage. That's used quite widely in the industry. And what I'm going to do is I'm going to show you that, let me switch over to the view here, that when I press this button, you should see the software LED on my dashboard. That should go red. And look, it does. It goes red, I release, it goes green, I press, in other words, sending a high, will turn the software LED red, releasing it, sending a software 0 to the LED, turns its state. Now, how did I do that? Well, let's switch back to the Node-RED dashboard. Okay, and you can see I sent a 1, I sent a 0, I sent a 1, and I sent a 0. Now notice, interestingly enough, the input from this pin, which is GPIO port 6, pin 31, well, Node-RED gave it the address of the pin number, okay, for the topic. The topic was PI/31. That is the Pi pin number 31. So I know which one that is. And if I want to see what port number it is for logic, then I can see that it's GPIO port 6 on pin 31, physical pin. So I'm going to clear this here real quick. And I'm going to show you what I've done with this LED. So the LED, let me get out of here and show you, if I go down, way down here to the Node-RED dashboard nodes that I've installed, as well as the LED node, then I pull that in and I've configured it. And here's how I've configured it. I've got the label that shows up on my dashboard in the group R/G, and I've set it so that when it sees a numeric value of 1, it goes red. And when I give it a numeric value of 0, it goes green. And I can set it as a circle, I can align the label, I can align the placement of the LED, and it goes into the group IoT is the tab, and out is the group number. We'll get to more about the dashboard here. We'll learn more about that later. But for now, you can see that I can control an LED from a hardware button. So we've gone actually both ways. We've gone from software control over a hardware LED to a hardware button into a software LED. So if you've been following along and have done the same thing I've done, you've taken your first major steps for interfacing a Raspberry Pi computer to your software and to your hardware and taking control over the world. So this is the beginning, and we're going to have a lot more fun doing a lot more interesting things in the near future. So now our next step is to have more automated control over our hardware LED. We can see our hardware LED in our camera view inset, and the LED is off right now, and we've connected it from the GPIO port 12 over here to the input of the resistor to the LED. And what you see up here is I've got the inject node set up as a pulsar, and it's going to pulse and send a true level, which is the same as a logic 1. So here's an introduction to Boolean logic. Boolean logic is basically true or falseness of a signal, usually associated with a high or a low. But here I've got a Boolean logic of a true state, and it'll send that true every 1 second. Okay? Now, I've also got it going into a trigger node. That means it'll send a 1, then wait for a half a second, and then it'll send a 0. Okay? And so what'll happen is I'm going to inject the output of that into my red LED sitting here at GPIO port 12 on pin 32. And I didn't hook this up because the minute I hook it up and I deploy, you'll see it start. You'll see it start flowing outputs, 1s and 0s, to the debug node. And if you look at the inset, you look at the LED, you should see it start to flash. Ready? Let's go. On, off, on, off, on, off, on, off. Now, what's also interesting, you see this flashing? This is telling you the state of this trigger node. And you can see the state flipping from 1 to 0 here on the red LED. Let me move the debug mode down a little bit. You can see the state flipping back and forth, back and forth, back and forth based on the pulsar. So you can see this, this software circuit in Node Red, this Node Red flow operating in real time. So that's an example of a kind of a semi-automated type of a system.